This is Learning Assessment Problem 1015. The problem-solving strategy here is that of circuits containing ideal transformers. We have a network here containing a transformer, and we'll label the left side as the primary of that transformer, the right side as the secondary of the transformer. And we are requested to determine the current I1, which is circulating in the left-hand loop in the circuit. And the instructions are to transform the secondary of the transformer and the transformer to the primary side. So we'll label some quantities here. We have that loop current flowing I1 that we're going to determine eventually. Let's label some terminals X and Y for the primary side of the transformer. We have a voltage source on the secondary side. We'll call that V2. We have an impedance of 2 ohms on the secondary side. Refer to the impedance seen into the secondary network as Z2, and the impedance looking into the primary of the transformer is Z1. We note that the voltage source V2 will tend to make the undotted terminal of the secondary winding positive, whereas we'll refer to the voltage across the primary side V1 positive at the dotted terminal. The turns ratio N for this transformer is indicated to be 2. So some relationships which we can write are that the voltage V1 is equal to minus the voltage V2 divided by the turns ratio, or in this case that's equal to minus V2 divided by 2. For the impedance transformation, we have that the impedance seen on the primary side is equal to the secondary impedance divided by the square of that turns ratio. In this case, Z1 is equal to Z2 divided by 4. We'll begin the solution by determining the equivalent circuit for the secondary side of the transformer and connecting that in place of the transformer on the primary side. So the V2 voltage source will transform to the primary side of the transformer according to V1 is equal to minus V2 divided by N, the turns ratio, which in this case is equal to minus 12 at an angle of 0 degrees volts, divided by 2, which is equal to minus 6 at an angle of 0 degrees volts. For the impedance on the secondary side, we'll transform to the primary side according to Z1 is equal to Z2 divided by N squared, and in this instance that will be equal to the 2 ohm resistance on the secondary side divided by 4, which is equal to 1/2 ohm. Now we can draw the equivalent circuit on the primary side of the circuit with these equivalent elements replacing the transformer in the secondary network. Here we've indicated the terminals of the primary side X and Y, and we have the original 36 volt source as well as that minus 6 at an angle of 0 degrees volt source reflected from the secondary side. So with this simple loop circuit, we can now proceed to determine the value of the loop current I1. Writing the expression for I1, we have, which is 42 at an angle of 0 degrees volts divided by 3.202 at an angle of minus 38.66 degrees ohms, or the current I1 is equal to 13.12 at an angle of 38.66 degrees amperes.